Meet TOML, TOML's obvious minimal language. It's a config file format designed to be easy to read and hard to mess up. Three of the most important tools in modern development rely on it. Cargo for Rust packages, Hugo for Go static sites, and pyproject.toml for Python projects. They all pick TOML because contributors shouldn't have to fight their build configs. Every TOML file is just a fancy dictionary. Keys sit on the left, values on the right, joined by an equals sign. Strings go in double quotes, integers are whole numbers, floats carry decimals, and booleans are simply true or false. Double-quoted strings honor escapes like \n, while single-quoted strings stay completely literal. When your config grows beyond a handful of lines, group related keys with section headers in square brackets. You can nest sections by using dotted names, like server.tls, which creates a table inside a table. The result is a clean folder-style hierarchy that mirrors the structure of your project. For tighter groupings, TOML gives you dotted keys, a way to assign a value deep into a structure without opening a new section. Writing physical.color equals red is exactly the same as creating a physical table and putting color red inside it. It keeps short, related settings compact and readable on a single line. Need a list of values? Use inline arrays wrapped in square brackets, with commas between items. For repeating groups of structured data, use arrays of tables with double brackets like items. Each double bracket block appends a new entry to the list, perfect for lists of dependencies, authors, or blog posts. Comments start with a hash and run to the end of the line. Perfect for leaving notes for future readers. And here's the big payoff. Because TOML structure is so regular, it maps directly onto a hash table. Brackets become nested maps, keys become keys, and arrays become lists. One config file, one in-memory data structure, zero ambiguity. In this demo we'll create a small TOML configuration file using printf, inspect its contents with cat, grep and wc, and then clean it up. The goal is to show exactly what each command does and what its output looks like so you can replicate the workflow on your own machine. Let's begin by clearing the screen for a clean workspace. The clear command wipes the visible scrollback and repositions the cursor to the top left corner. It produces no output. Its job is purely cosmetic, leaving you with a pristine workspace. After pressing enter, you simply see a fresh prompt waiting for the next command. Now we use printf to write a TOML file. The single quotes wrap the format string, and \n inserts the line breaks the TOML parser expects between sections and keys. The redirect sends the formatted output into /tmp/s.toml instead of printing it on the screen, so this command also produces no visible output, only the next prompt. With cat we dump the entire file to standard output. You can see four logical pieces. A server, table with host set to localhost and port set to 8080, and a logging table with level set to info. TOML structure is human readable on purpose, and cat is the simplest way to verify what actually landed in the file. Grep, nport searches for the word port, and prints every matching line along with its line number. We get a single hit, line 3, showing port equals 8080. The N flag is invaluable when you're scanning a longer config file, and need to know where a setting lives before you edit it. WC, L counts lines of text. TOML files use new lines as structural delimiters, so the count of 5 corresponds to the 2 section headers plus the 3 key value pairs. The output shows the file name, the count, and the label lines. This is a quick sanity check that nothing was truncated or pasted into a single line. rm/tmp/s.toml deletes the file, and once again there is no output on success. The Unix philosophy is no news is good news. The next prompt simply reappears, ready for input, with no error or confirmation message printed. Finally, ls/tmp/s.toml is our proof step. Because the file no longer exists, ls reports the exact error, no such file or directory, along with the path that failed. This pattern, perform a destructive action, then list or stat the target to confirm, is a habit worth keeping for any cleanup workflow. TOML looks different depending on where you find it, but underneath, it's the same language every time. Let's pull 3 real configs from 3 real ecosystems, and compare them panel by panel. Panel 1, Rust cargo.toml. The package, header opens the project's identity block, and dependencies, opens the crate list. Notice the inline table next to Tokyo, braces pack version and features into a single key, and the features list is an inline array wrapped in square brackets. Panel 2, Python's pyproject.toml running on Poetry. Instead of nesting brackets, Poetry uses dotted keys. Tool.poetry reads as a single chain path. The header, tool.poetry.dependencies, is the deepest level, and a tool.poetry.scripts header exposes a console entry point. Panel 3, Hugo's config.toml. Top-level scalars sit directly under the file with no header at all. The params header groups site metadata, and the taxonomies header maps classification concepts, and one of them, series, holds an inline array of slug strings in square brackets. 3 files, 3 ecosystems, identical primitives. Headers group related keys. Dotted keys flatten nested namespaces like tool.poetry.dependencies without extra nesting. Inline arrays, written as ABC. Embed lists without taking a full line each. Now the inevitable question. Why TOML instead of JSON or YAML? TOML leans toward human readability through explicit headers and minimal punctuation. JSON is unbeatable for machine-to-machine data, but requires quotes and braces everywhere. YAML is the most human-friendly until indentation tricks you. And it doesn't natively support features like Cargo's inline tables. TOML fits best when humans edit configuration by hand. Cargo manifests, Python project metadata, Hugo sites, npm overrides, and game engine projects. JSON dominates APIs and stored data. YAML dominates Kubernetes manifests and CI pipelines where tools generate the file. Pick the language that matches who writes it most often. TOML for humans, JSON for machines, YAML for both with care. We're starting with a sample TOML configuration file at /tmp/cfg.toml. The file contains dotted keys like database.primary.host and an inline array for allowed_ports. Let's work through it step by step in the terminal. The cat command prints the raw contents of /tmp/cfg.toml to the screen. You can see the section header database.primary, the nested key host set to localhost, and the inline array allowed_ports with values 80, 443, and 8080. Running grep with the n flag numbers every line of output, even blank ones. This is useful for verifying the structure of a file and counting its lines before parsing it programmatically. Python 3.11 added TOMLib as a built-in module for parsing TOML files, so no installation is required. This one-liner opens the file in binary mode, parses it, and prints the resulting dictionary to confirm the data was read correctly. Now we remove the configuration file to clean up. After pressing enter, the prompt returns with no output, confirming the file was deleted successfully.